So, welcome back to my channel. And by the way, I'm Gutierrez Channel Day, and for today's video, I'm going to make a summary video for chapter 7, which is summary 2.7. So, summary 2.7 entitled IP addressing. So, addressing is a critical function of network layer protocols. Addressing enables data communication between hosts, regardless of whether the hosts are on the same network or on different networks. So, both Internet Protocol version 4 (IPv4) and Internet Protocol version 6 (IPv6) provide hierarchical addressing for packets that carry data. So designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. So this chapter examines in detail the structure of IP addressing and their application to the construction and testing of an IP networks and subnetworks. So for more summary, let's watch this. So here we have the IPv4 address. So we all know that the IPv4 address is Internet Protocol version that's a lower than the Internet Protocol version 6. So addressing is a critical function of a network layer protocol. So addressing enables data communication between hosts regardless of the whether of the hosts are on the same network. So on different networks, both Internet Protocol versions provide hierarchical addressing for packets that carry data. So even if it is IPv4 addresses or IPv4 6, even they are not same bits, and it's provide a same. So it is it is provide the same it is provide a hierarchical addressing for packets that carry data, even they are not in the same version. So binary is a numbering system that consists of the numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting of the numbers 0 to 9. So binary is important for us to understand because host servers and network device uses binary addressing. Specifically, they are used binary IPv4 address as shown in figure 1. So here we have a positional notation. So we have a radix, position number, calculate, and position value. So binary to decimal conversion. So we have a position here in position value, binary number, calculate, and add them up and the result. So if you add the two value one here, and binary value, so the sum of these two is 128 plus 64 is equals to 192. So that's the how you convert the binary binary number to have the to decimal. So we have here a 10101000. So if you add the 128, the 32, and the 8, the sum of this binary number is equals to 168. So we have a 192.168. Then here we have a 000111. So binary value is a 8, and you have 2, and you have 1. So if you add them up, the result is 11. So we come up to this answer 192.168.11 by just adding the binary number which have a one value. So the last one, we have a 0 0 0 0 1 0 1 0. So if you add the 8, 2, and 1, the answer is equals to 10. So here, as you can see, the answer is 192.168.11.10. So binary to, that's how you convert the binary to decimal conversion. So the next is we have a decimal to binary conversion. So this is the diagram or the loop to convert the decimal to binary conversion. So the subnet mask, the IPv4 address, unique IPv4 address of the host. Subnet mask used to identify the network host portion of the IPv4 address. So default gateway identifies the local gateway, i.e. local router interface IPv4 address to reach remote the networks. So the actual process used to identify the network portion and host portion is called ANDing. So here it said that the process that you to identify the network portion and the host portion is called ANDing. So ANDing is you have a 1 and zeros. So 1 and then 1 is equals to 1. So if you have a 2 value of 1, so it is equals to 0. Then if you have a 1 ending 0, so it's equals to 0. So the next is we have 0 ending 1, it is equals to 0, and also is 0 ending 0 is equals to 0. So the subnet mask does not actually contain the network or host portion of an IPv4 address. It just tells the computer where to look for these portions in a given IPv4 address. So like I said, so logically end, so 1 and 1 is equals to 1, 0 and 1 is equals to 0, 0 and 0 is equals to 0, 1 and 0 is equals to 0. So a logical AND is one of the three basic binary operations used in digital logic. The other two are OR and NOT. So while all three are used in data networks, only is used in determining the network address. So here we have a binary value here and subnet mask and end result. So here if this number doesn't have a 1 and 1 value here, so the value is equals to 0. So if the value have a 1 and 1 here, so the value is equals to 1 and 0, so it's equals to 10, and then 168, and then here we have a 1 1 1 1 1 1. So it's so we have this 1 1 1 1 1 1. So you have a 2 value of 1. So if you add the 128 plus 64, the answer is equals to 192. Here we have 1 here, and we have your 1 here and 1 here. So if you add the numbers, it should be 168, and here we have a 1 1 2 4 8. A 8 plus 2 is should be is equals to 10. So the next slide is the prefix length. So the prefix length is the number of bits set to 1 in the subnet mask. So by by to get the prefix length, just count the number 1 value in every bit address. So if you count the value here, 1 2 3 4 5 6 7 8. So the prefix length for subnet mask 255 32 bits is 8. So and so forth. Just count the value 1 to get the prefix length. So we have a network host and broadcast address. So network is address and subnet mask refer to the network. All hosts with the network share the same network address. So we have host address, unique IP address assigned to hosts and devices. So the host portion always contain sorted zeros and ones but never all zero or all ones. So first host address, first available host IP address in the network. The host portion always has all zeros and with a 1. So last host address So it should the same, and broadcast address, a special address that communicates with all hosts in the network. So IPv4 communication, we have a form of communication here. We have unicast, broadcast, and multicast. So for unicast, it's a sending a packet from a host to an individual host. In broadcast, in the process of sending a packet from one host to all hosts is in the network. And multicast, the process of sending a packet from one host to a selected group of hosts, possibly in different network. So in unicast, it is sending a packet from host to individual. In broadcast, is sending a packet from one host to all hosts. But in multicast, it should be sending a packet from one host to a selected group only. So public and private IPv4 address. So the private address blocks are 10.000 or -8 or 10.000 to 10.255.255.255 and 172.16 and 0.7.0 and 192.168 and 0.0. So these addresses is the that private address that blocks. So the next is we have a special user IPv4. So in loopback address, the address is 127.7.7.7-8. So it's more commonly identified as only 127.0.0.1. These are special address used by a host to direct traffic to itself. So loopback address is the special address used to used by a host to direct traffic itself. So in linked local address, we have 169.254.0.0. So it's more commonly known as the automatic private IPv4 addressing or APIPA addresses. They are used to by Windows DHCP client to self-configure in the event that there are no DHCP servers available. So testnet. So the address of it is 192.02.2.0. These addresses are set aside for teaching and learning purposes and can be used in documentation network example. So in this IPv4 address, every addresses doesn't have common meaning or common uses. So the next is the legacy classful addressing. We have class A, class B, and class C. So IPv4 and IPv6 coexistence. They have dual stack as shown in figure dual stack and allows people to exist on the same network segment. So dual stack device run both IPv4 and protocol stack. So coexistence means those two protocol can have this network segment, these devices. So dual stack tunneling and translation. Rules in omitting zero. So here just remove the zero value in the front of your preferred number. So as you can see here 2001, then it's 0 db8, so it should be db8, and here just remove the 0 and it's only 10 here, so it's like in the first 0 0 0, and in the front of 0 to 100 the 0 here is removed. That's the rules in omitting 0, removing the first 0 in your value. So the compress is 2001, db8, 0111, and 200. So the IPv6 address types, we have unicast, multicast, and anycast. So we have a global unicast, link local, and unique local. And structure of an IPv6 global unicast, we have global routing prefix. So the global routing prefix is the prefix or network portion of the address that is assigned by the provider. So we have subnet ID. Subnet ID is used by an organization to identify the subnets within its site. So interface ID, the IPv6 interface ID is equivalent to the host portion of an IPv4 address. So we have dynamic configuration is LAAC, network prefix and prefix length, default gateway address, and DNS address and domain name. So Slack is stateless, which means there is no central server. For example, a stateful DHCPv6 server. So along global Unicast address and keeping a list of devices and their addresses. So we have a prefix and interface ID. So in prefix, receive in the RA message. In interface ID, uses the EUI64 process or by generating a random 64-bit number. This is the EUI64 process and randomly generated. So IEE defined the extended unique identifier EUI or modified EUI64 process. This process uses a client 48-bit Ethernet MAC address and inserts another 16 bits in the middle. So organizational unique identifier or OUI is a 24-bit 6 hexadecimal digits vendor code assigned by IEE. So the device identifier is a unique 24-bit 6 hexadecimal digits value with in a common OUI. So randomly generated interface is depending upon the operating system. The device may use a randomly generated interface ID instead of using the MAC address and the EUI process. So we have ICMP and ICMP-v6. So we have a host confirmation, destination or service unreachable, time exceeded. So ICMP-v6 router solicitation and router advertisement messages. So in address resolution is used when a device on the LAN knows the IPv6 unicast address of destination but does not know its Ethernet MAC address. So in duplicate address detection, when a device is assigned a global unicast or linked local unicast address, it is recommended that that is performed on the address to ensure that this is unique. So the last one is traceroute, testing the path. We have round trip time or RTT. So using traceroute provides round trip time for each hop along the path and indicates a hop fails to respond. So this information can be used to locate a problematic router in the path. So in IPv4 TTL and IPv6 hop limit, traceroute make use of a function of the TTL field in the IPv4 and the hop limit field in the IPv6 in the layer 3 headers along with the ICMP time exceeded messages. So that's all for today to this video. So I hope you will learn and understand this chapter. So thank you for watching.